Good morning, my dear friends. I hope you all are doing good. So today we'll be talking about pressure volume work. And here we will understand irreversible work and reversible work. So first of all, let us take on irreversible work, my dear friends. So what will be this irreversible work all about? Let's have a look. My dear friends, if I take on a cylinder here, a closed cylinder here, correct? So what I'm going to do is that it is fitted with a piston. A cylinder is fitted with a piston. Let us suppose this piston is a frictionless piston. That means it can easily move up and down, my dear friends. Correct? So inside this particular cylinder or closed vessel, we can see some gas is present. Let us suppose some gas is present here inside. So there is a gas inside. And this gas is an ideal gas. And let me take 1 mole of this ideal gas. So how many moles of ideal gas are present in this cylinder? We have 1 mole of ideal gas here. And now this cylinder is fitted with a frictionless piston, that means which can easily move, up or down, or which can be easily made to move up and down, correct? Now my dear friends, let us suppose I will keep some weight here on this piston. 1 block I will keep. Any weight I can use, my dear friends. I can keep some weight, let's suppose W, onto the piston. Yes. When I keep the weight W onto the piston, my dear friends, what happens? It will exert the pressure on the gas. Which gas? Ideal gas, which is inside. So this will be your P external. Let us suppose because of this weight which I have kept on the piston or over the piston, yes, we have gotten some P external. That external pressure is, let us suppose, 1.5 atmosphere, let us suppose, because of this weight. Yes, and because of atmosphere also. Okay. It's 1.5 degree. And now this ideal gas will also exert the pressure onto the piston from the lower side, correct? So this ideal gas will exert the pressure onto the piston, and let us suppose that pressure is called as P internal, that is called as internal pressure, my dear friends. So P internal is nothing but its pressure due to ideal gas. In a cylinder, correct? Let us suppose for time being, P external is greater than P internal. P external is greater than P internal. That means P internal should be less than 1.5 atmosphere. And let us suppose this 1.5 atmosphere is a constant pressure now, external pressure. I am not going to change the external pressure. When I kept some weight onto the piston, now the external pressure was 1.5 atm, let us suppose, and let us keep it constant. Let us not put any more weight on the piston to increase the pressure, or let us not remove the weight from the piston to decrease the pressure. Let us keep this weight on the piston and the pressure will remain constant. Let us suppose the pressure is 1.5 atmosphere and it is constant. Okay? Now what happens? P internal is basically pressure due to which gas? Ideal gas. How many moles of ideal gas you have? 1 mole of ideal gas. So my dear friends, if the P internal is less than P external, that means P internal has to be less than 1.5 atmosphere. That means pressure due to ideal gas should be less than 1.5 atmosphere. When this thing happens, then external pressure, yes, will make the gas to compress. Because we know that external pressure is 1.5 atmosphere, let us suppose, and internal pressure is less than the external pressure. So which means the piston will come down, it will compress the gas. Piston will compress the gas. Have a look here. Let us suppose this was the initial position of the piston and the volume here will be Vi, that is the initial volume. And we know that P external is greater than P internal, let us suppose. Then what happens? The piston will move down. It will do the work on the ideal gas. That means the gas will be compressed. Let us suppose this was the initial volume right out here. So from here to here we have initial volume. And now from here to here we will have final volume. So this is nothing but this is the work of compression. So here the work of compression is happening. Gas is being compressed because let us suppose that P external is greater than P internal, my dear friends. And how much is the P external? You have kept 1.5 atmospheres and the P internal should be less than this. When it is less than this, then only the gas will be compressed. So once the gas compresses, it is happening in just in one step. So when some change happens in one step, okay, and that change is a bigger change, it cannot be reversed. So the work will become what? Come on, irreversible work, man. So work of compression, okay, it happens in just one step. So when work of compression happens just in one step, okay, and the change will be a little large, so this change cannot be reversed. So dear friends, let's have a look at. You know that this was the initial value, right? From here to here we have initial value, and from here to here we have the final value. What we are doing work of compression, and it happens in just one step. So it's an irreversible process, and the work will be irreversible work, my dear friends. Now the piston is moving down, so it will cover some distance. Let us suppose that distance from here to here is L. So L is nothing but the distance covered by the piston while doing the work of compression. While doing the work of compression, piston will cover some distance, and that distance is here L. So L is what? The distance covered by piston during work of compression, because gas is compressed here, my dear friends. And one more thing is there. If we talk about this piston, the piston will have the area, okay? The area of this particular piston is compressing a particular gas, ideal gas. So we will write down here, A is the area of cross section of piston. So my dear friends, we will take this one, the area of piston, as A. So my dear friends, piston with area A, area of cross section A, is compressing the gas, okay, and there is a decrease in volume. Volume is decreasing from Vi to Vf. So one more factor I will tell you, volume is decreasing from Vi to Vf. That means volume decreases. That means we are doing the work of compression. And when the piston moves down, it covers a distance L. So L is the distance covered by the piston with area of cross section A. So the change in volume will be area into the distance. That will be the change in volume. So my dear friends, in this irreversible work, the change in volume will be given as area of cross section of piston, multiplied by L, the distance covered by the piston. And this change in volume can be finally represented as delta V. friends, you have understood now the change in value, okay, of a system will be area of cross section of piston multiplied by the distance traveled by the piston. Okay, that is delta V. And it can be also represented as final minus initial, because it's a state function. Everybody knows this guy is a state function. So that is Vf minus Vi. So my dear friends, afterwards what we are going to do is that everybody knows that pressure is equal to force per unit area. Force per unit area. Okay, my dear friends. Now what is happening here? If I talk about force, then force is equal to pressure into area. This force is equal to pressure into area. And this pressure is P external, my dear friends. And we know that our P external is constant. And roughly I have taken one constant value for this, that was 1.5 atmosphere. That was just a rough value. Okay, you can take it as 1 atmosphere, but don't change it. Keep it constant only, let us suppose. And we know it was constant only. So after that what happens? The force is equal to pressure into area. Correct, my dear friends? Now everybody knows one expression you will be knowing about here, that work is equal to, okay, force multiplied by displacement. You can write down, or you can write down distance. Yes, my dear friends, let us call it as, let us suppose, equation number 1. Okay, and we know that the force is equal to pressure into area. So in place of this force, I can write down pressure into area. So I'll tell, let us substitute the value of force in equation 1 we get. So my dear friends, let us see what we are going to get. Let's take on the work here is equal to force. If you look here, force is equal to pressure into area. So in place of force, I will write down P external into area of cross section and multiplied by the distance. And we know that this distance, look here, this distance is L. So this L is the distance actually covered by the piston. So this is the distance covered by piston, which is equal to L. So in place of this distance, I can write down L. So my dear friends, now work is equal to P external into area of cross section, because P into A is nothing but it is the force. P into A, P external into area of cross section of piston is the force, because force is equal to P into A and work is equal to force into displacement, or we can say distance. The force, as in place of force I wrote pressure into area, and in place of distance we wrote L. So this is the expression in us. So afterwards, my dear friends, what we are going to do, have a look here. Let's talk about now the work is equal to, we know that area into length, you know the value of area into length, that is nothing but change in value. So my dear friends, as we know, let's call it as equation number 2 here. As we know that area of cross section multiplied by the distance covered by the piston is equal to delta P. So we know this particular thing right from the beginning itself. Change in value is area into length, that is delta V. So my dear friends, area of cross section of piston multiplied by the distance covered by the piston is equal to delta V. Substitute the value of area into length in equation 2 we get. You know my equation 2 is here, that is W is equal to P external into area of cross section into length. and we know the value of area of cross section into length. Area of cross section into length is change in value. So in place of this A into L, I can write down delta V. So my dear friends, in place of A into L, I will write down delta V. And we know that this is an irreversible work, so I will mention it like this. W irreversible is equal to P external into delta V. But I am using a minus sign here. Now you can ask me, sir, why you have used the negative sign here, which I am going to tell you afterwards. Please make note of this thing first. My dear friends, you will be thinking now that why did I use the negative sign here? Why this negative sign is used? Okay? Because if you see the previous expression, there is no negative sign here, but I am using a negative sign here. What is the reason? Remember, this is an irreversible work, but this is the work of compression. I can also call it as irreversible work of compression. Irreversible work of compression, my dear friends. And why I have used this negative sign? The question will be that, why negative sign? Let's explain it. Previous time I told you, my dear friends, if I take the same expression here, work irreversible is equal to now minus P external delta V. Why I am using the negative sign here, let us understand. You know that if I talk about work of compression, it means work is done on the system. Yes? So when work is done by the system, when work is done on the system, so work has to be positive. Work has to be positive. That's why this negative sign is used to make the work positive. Yes? I'll write down here this negative sign is used to make work positive. Now you will be thinking still that how the work will become positive. Have a look. You know that if you look here, delta V, my dear friends, let's have a look. Work irreversible is equal to minus P external. In place of delta V, I can write down V final minus V initial, my dear friends. And we also know that it's a work of compression. My dear friends, it's a work of compression. In work of compression, everybody knows that initial value is greater than final value. Initial value is greater than final value. So if initial value is greater and final value is smaller, you have seen in the work of compression. So this Vf minus Vi will give me which value, my dear friends? So Vf minus Vi, we know that in this case Vi is greater than Vf. We know this thing. So here I will get the negative sign. So P external minus sign here, so it's work. So negative into negative, minus into minus will become plus. So finally the work will be the positive. That is the work done on the system. Once again I am telling you, I have this expression. Beginning I had this expression, there was no negative sign. But I used the negative sign here, and why negative sign I am using? So if you look at this negative sign is used to make the work positive. Why we are making work positive? Because work of compression we are doing. Work is done on the system, so work has to be positive. When work has to be positive, why work has to be positive? Because the internal energy of the system will increase when you are doing work on the system. So it has to be positive. So when I use this negative sign here, you look here, then I use my expression P external, which is constant, and delta V is equal to Vf minus Vi, correct? And we know that out of these two terms, Vi is greater than Vf. So Vi is greater, so negative sign will remain here, because negative is greater. So negative into negative will become what? Positive. So work will become positive. Minus into minus will become plus. I hope you have understood, my dear friends. Okay? Please make note of this. So my dear friends, now let's have a look. For this irreversible work, we will draw a graph between pressure versus value. And you know that in this particular process I told you that external pressure is constant. So let us suppose this line will give me P external, and remember it's constant. So pressure along this line the pressure is here, that is P external. On y-axis it's constant, it has a fixed value. But in work of compression pressure is constant, okay, irreversible work, but the value is decreasing. Value is decreasing, my dear friends. So let us suppose value decreases from Vi to Vf. So my dear friends, this decrease in value or change in value will give me the work. So if I shade this particular area, this shaded area will give me the work, because during this work the external pressure is constant but value is decreasing from Vi to Vf. Means Vi is greater than Vf here. My dear friends, Vi is greater than Vf, which means we are doing work of compression. We are compressing the gas. And while compressing the gas, we are doing only in one step. So it is which work? It is the irreversible work. Okay, it's done in one step. Done in one step. And it brings the change in value is here. Change in value happens to be delta V, my dear friends. And obviously, the work will be given by this shaded area. Yes, I know P external is constant but value is decreasing. So it's a work of compression, my dear friends. Please make note of this thing. And simultaneously, if we go further, if we summarize this entire process, we can do it easily. But before that, you please have a look at this and make note of this. So let us summarize it. Let us summarize it. Irreversible work of compression. So whatever we have done, we will try to summarize it in just few minutes. P external was constant. Yes. P internal is the pressure due to ideal gas. Due to ideal gas. This expression was that P internal was less than P external, or we can write down P external was greater than P internal. Yes. So when this thing is happening here, this will lead to the work of compression is possible here. If internal pressure is greater than external pressure, then work of expansion is possible. So this will lead to the work of compression. Okay. So after that, A was the area of cross section of piston, or we can directly tell area of piston. L was the distance covered by the piston. Distance covered by piston. And the change in value was actually area into length. The change in value also represented by Vf minus Vi. My dear friends. And we also know that force is equal to pressure into area. Yes. And we also know that work is equal to force into distance or displacement. Yes. So my dear friends, look here. Now work is equal to, in place of force is equal to P into A. So I will put in place of force, I will put P external into A. And in place of distance, I will put the length, this one. Distance covered by the piston. And we know that area into length is nothing but it is the change in value which I got here. The change in value. That is area into length. Change in value is area into length. So in place of this I will write down W is equal to P external into delta V. And then what I did after that, I wrote a negative sign here. I wrote a negative sign here, minus P external delta V. And then I told you the meaning of this negative sign. Why this negative sign is used? Because we know already that delta V we are talking about will be a negative. Why? Because initial value is greater than final value. This negative into this negative will become positive. So this was the work of compression, expression for work of compression. But if you take the work of what? Expansion. Irreversible work of expansion is there. So let us see the expression for that. This is the expression for irreversible work of compression. Why we call it as irreversible? Because this process cannot be reversed, because the change is large, and that change is basically delta V. It's a bigger change. So obviously this is our irreversible work, but irreversible work of compression. Now let us talk about the irreversible work of expansion. That means if now expansion of gas happens, what will happen? The work has to be negative. If there is the irreversible work of expansion, the term will be very easy here. Same situation but in opposite direction. Now look here, we will be having work irreversible here equal to minus P external delta V. But remember this, in case of expansion, you should always remember that initial value will be less than final value. Final value will be greater here. So remember that. So we know here that change in value will be given by minus P external, delta V can be written as Vf minus Vi. And I told you, when there is an expansion of gas, let's suppose this is initial value, and when this gas will expand, what is going to happen after the expansion? The piston will move a little bit up, because gas is actually expanding. So it will cover a distance L. But here, the point here is that the gas is expanding here. Which gas? Ideal gas is expanding. So this is the initial value and this is final value, and obviously the final value is greater than initial value because we are doing the work of expansion of gas. And this is also irreversible because this process cannot be reversed. Okay? Have a look here. Vf minus Vi. We know that Vf is greater than Vi, so this value will be positive. So negative, and this P external and this value will be positive because Vf is greater than Vi. So this is greater than this, so positive value. And overall, plus into minus will be minus only. So work is negative. That means the irreversible work of expansion. That means work done by the system. Because gas is expanding, so work is done by the system. So work done by the system is negative. Why work done by the system is negative, my dear friends? Because while doing the work, the ideal gas will lose its energy. So that's why the work becomes negative right out here. Please remember that. And in next class, we'll be talking about reversible work. And that reversible work does not take place in just one step. And change will not be large. In case of reversible work, it takes place in multiple steps. Hundreds and thousands of small steps. We call them as differential steps. So I hope you have understood today that when it's an irreversible work of compression, the value will decrease, and obviously at the end, the work will come out to be positive. Because I have used the negative, symbol at the beginning, a negative sign I have used to make it positive for compression. And for the expansion of gas, expansion will be also the irreversible process here. Okay? And the work has come out to be negative at the end. So with these terms, I would like to end up today's session. Have a great time. All the best.